Okay, today we will deal with the integumentary system. Just to remind you where we are, we studied the cell, and then we moved up in the levels of organization of an organ or organism to tissues. We studied some of the tissues, major tissues, the connective tissue and the epithelial tissue, and today we are going to move to a system, which is a group of organs, and which consists mainly actually of connective tissue and epithelial tissue. So the integumentary system consists of several organs. The main organ, actually, it consists of the skin, which is in fact the largest organ in the body. It also consists of some other appendages which can be considered as organs. That's why the whole is considered as a system, because when organs come together, they form a system. Here, the biggest organ is the skin, and the others, which are called skin appendages, they include the hair, the nails, the glands, which are sweaty glands, and including the mammary gland. By the way, the mammary gland is considered as a modified sweaty gland. We're going to study it later on with the female reproductive system and the sebaceous gland, and also it contains some sensory receptors and blood vessels. In this optional video, if you like to watch it later on, you will find Gunther von Hagens, the guy who invented plastination. So he's dissecting the skin in its entirety, and you can see why the skin is the biggest organ in the body. The skin consists of several tissues. It consists of epidermis and the dermis. So the epidermis is the superficial layer, and you can see it is usually thin. It is thinner than the dermis. It is the superficial layer, and tissue-wise, it consists of keratinized, stratified squamous epithelium. If you remember the types of epithelium, so this is stratified, multiple layers. It is squamous. The most superficial layer is flat, and it has a lot of keratin, because some stratified squamous epithelia are non-keratinized, like the ones that line the mouth, for example. The dermis is the deeper layer. It is the thicker layer, and you can see it here, and it consists of two sublayers. We're going to talk about them in details: a papillary layer, which is thin, and then a reticular layer. The papillary layer is loose connective tissue, and the reticular layer is dense, irregular connective tissue. And then I remind you of the types of connective tissue that we mentioned last time: loose, dense, and then the loose has subtypes and the dense has subtypes. And then deeper to the skin is the subcutaneous tissue, which loose connective tissue, and in many places in the body, it contains a lot of fatty tissue, as you can see it here. This is called the subcutaneous layer. Sometimes they call it the superficial fascia. It lies just underneath the skin. So now let's deal with in more details with the epidermis. And the epidermis consists of, as I said, keratinized, stratified squamous epithelium. But there are four types of cells. The main types of cells that are present in the epidermis are called the keratinocytes. So we have keratinocytes, we have melanocytes, we have the Merkel cells, and we have the Langerhans cells. The keratinocytes are the most common type. 90% of the cells in the epidermis are keratinocytes, and they produce a protein in the form of fibers that are bundled together, which make it tough. That's why it's called keratin, because keratin means horn-like. So it makes it tough for the protection, of course. The reason is for protection. And the cells are called keratinocytes, the cells that produce keratin. They are the most abundant cells. The second type are the melanocytes. Again, these are the cells that produce melanin. Remember, we mentioned about melanin before when we were dealing with like inclusion bodies, which are present in the cytoplasm. We mentioned that there is one of them is the melanin pigment, and this is produced by melanocytes. Look at the melanocytes. They are present in the deeper layer of the epidermis, and the cell has multiple processes, long processes that pass in between the cells of the more superficial layers, and the cells produce melanin pigment, and the melanin will be distributed in these processes. Processes are taken up by the surrounding cells, and that's how they get into the nearby cells. And they form like an umbrella for the nucleus of the cell. Remember that these cells, they are rapidly dividing cells. So melanin protects against ultraviolet radiation, because ultraviolet radiation might cause an abnormal DNA. During cell mitosis, during cell division, the DNA has to replicate to start with, and then the cells divide, and each cell will take an equal amount of DNA. So there is rapid and continuous multiplication of DNA, and because of the ultraviolet light, this might result in an abnormal DNA and might result in tumors. Like, for example, here, as you can see, a patient who has repeatedly exposed his skin to ultraviolet light, resulting in skin cancer. That's why we have to put the sunblocks to avoid the ultraviolet radiation. The number of melanocytes in our skins are almost the same, but the difference in color depends on the amount of melanin that is produced. Whenever there is, depending on race, of course, and whenever there is an increased amount of sunlight, there is more melanin produced by cells, but the cells are the same. And also there is melanin which is dark brown, and there is melanin which is yellow-red, so containing more iron and sulfur. So that's why there is a difference in the color. So it's amount of melanin and the type of melanin that we have. But the melanocytes are almost the same. And melanocytes, as I mentioned, they are only present in the deepest layer, but their processes extend in between the more superficial layers. Then the third type of cells that are present in the epidermis are called intraepidermal macrophages, or their other name is Langerhans cells. Remember, the name of Langerhans was mentioned last time when we dealt with the islets of Langerhans in the pancreas. This is a different issue. These are multiple cells that produce hormones. But here we are talking about Langerhans cells. They are like macrophages, like the macrophages that are present in the alveoli and in the connective tissue. So these are macrophages. They are produced in the bone marrow, and they reach the skin. They sit there, and they are located in the more superficial layers of the skin. They are important for the immune response against microbes. Then we have the fourth type, which is called tactile epithelial cells, or Merkel cells. As the name indicates, tactile means that they are going to sense, so sensation. Tactile sensations that arise from the skin, tactile sensation. They are located in the deepest layer, and they are closely related to a sensory nerve ending. So that's why so they can transmit the impulse to the nerve. Okay, so they detect touch sensation. So 4 types of cells. These cells are arranged, because it is a stratified epithelium, so they are arranged in layers, and we have 5 or 4 layers. Stratum basale, as the name indicates, the basal layer. Also, it's called stratum germinativum, sometimes they call it, because it's the germinal layer. It's the layer that is multiplying and cells undergoing cell division and producing new cells that are pushed to the more superficial layer until they shed, a process that takes about 4 to 6 weeks. And then there is multiple layers forming a stratum spinosum. And then there is another layer which is characterized by granules on the cytoplasm. So it's called stratum granulosum. And then there is the stratum corneum, multiple layers of dead cornified cells. Sometimes in thick skin, there is another thinner layer which is called stratum lucidum. So it is with or without stratum lucidum. Now we have 2 types of skin, thick skin and thin skin. And here I'm talking histologically speaking, not literally speaking. Like literally speaking, a person with thick skin is the one who is like insensitive to criticism or something like that. But I'm talking about histological thick skin. A histological thick skin, the thickness, when we say thick or thin skin, it depends on the thickness of the epidermis. So you can see here in this histological section that the epidermis is very thick. So this is thick skin, and here the epidermis is thinner, definitely, than this epidermis. There is usually they have very thick stratum corneum, and they have stratum lucidum in addition. But here the stratum corneum is thin, and there is no stratum lucidum in between them. Now you need this thick skin in areas where they are subject to a lot of friction. So the thick skin is present in the palm of the hand, and it's present in the sole of the foot. So it's not most of the skin. Most of the skin is thin skin, but thick skin is present in these two areas, the palm and in the sole. And obviously, if you look at your palm and then the dorsum of the hand, you will find that there is no hair. Of course, there is no hair and no sebaceous glands in thick skin. But in thin skin, there are hair, sebaceous glands, sweaty glands. But definitely there are sweaty glands in thick skin. Like sometimes you feel that your palm is sweating. So there's no hair in thick skin. There are a lot of sensory receptors in this thick skin. That's why when we want to feel something, we are going to feel it with the palm of our hand or even with the tip of our fingers. But there is less sensory receptors in thin skin. Thin skin lacks stratum lucidum, as I mentioned, and contain fewer sweaty glands and sensory receptors, and also it lacks the epidermal ridges. I'm going to talk about the epidermal ridges in a moment. These are the ridges that are present on the surface of the skin, and they are reflection of these papillary ridges that are present here, and they have a pattern. In other words, they constitute what we call the fingerprints. So they have a certain pattern. This is not present in thin skin. Now let's start with stratum basale. As I said, this is the deepest layer. It's a single row, mainly of keratinocytes, which are cuboidal or columnar cells. You can see them here. Some of them are undergoing cell division. These are stem cells that are giving more and more keratinocytes. And sometimes it's called stratum germinativum, as I mentioned. There are also melanocytes in this stratum. The cell body itself is present in the stratum basale, but the processes extend in the other strata. Tactile epithelial cells are present here. It's only the Langerhans cells, which are the macrophages, are not present in it. They are present in the more superficial layers. So three types of cells we have in the stratum basale. In stratum spinosum, it is more superficial to stratum basale and consists of multiple layers, maybe 8 up to 10 layers of cells. And as you can see that the cells were cuboidal or short columnar here will become like polyhedral, multiple surfaces, and then become thinner and thinner as we go to more superficial layers. These cells, they are connected with each other by junctions. Remember the types of junctions that we had before? Here, the most common type of junction between these cells are the desmosomes. And these are strong junctions between the cells. So they prevent separation of the cells from each other. Now, during tissue preparation, I hope that you have watched the short video about the optional short video about the tissue preparation from last lecture. Usually there is a shrinkage of cells and shrinkage of tissue because the tissues are treated with increasing concentration of alcohol, and then this will take the fluid from inside the cell and replace it with alcohol, and then it's replaced by wax. So the cells will shrink. So if we have, like, for example, here, like this cell and then this cell and this one here, they are connected with each other by desmosomes, and then the cells shrink. So the sites of connection of desmosomes will not shrink. And that's why the cell, after shrinkage, because it's connected by multiple desmosomes, so it will have like spines or thorns. And when you look at it under the microscope, you will find these thorns or spines. They are normally there are no spines, but because of the tissue preparation, these spines became apparent because of the site of connection between these cells, the desmosomes. And that's why it's called the stratum spinosum. Usually the cells, they don't have spine in life, but because of tissue preparation, the scientists, when they named that layer, they named it, they were misled by what they saw at the first time, and they thought that these cells have spines. So that's why it's called the stratum spinosum. Remember that desmosomes, they don't form belts around the cell, but they form like spot-wheeled like spots. That's why the cells will be connected at certain points, not all around the cell, like the adherence junctions. Now, if we go a little bit higher, there are a few layers, about 5 or 6 layers of stratum granulosum. These cells are starting to die, what we call a process, a programmed cell death, a process which is called apoptosis. So they are going to lose their organelles, going to lose their nuclei, and they also contain granules in the cytoplasm. These granules in the cytoplasm are contain a substance which is called keratohyalin. So it will be released into the cytoplasm from the granules and will bundle the keratin that has been produced. All these cells, during their journey to the superficial layers, they are producing keratin as filaments. And then when the keratohyalin is released, it will bundle the keratin together so that it becomes tough. So that's why they are called granulosum, because they contain this keratohyalin, or these keratohyalin granules, of the precursors of the keratin. And also these cells, they produce like a lipid-like substance which acts as a sealant for the cells, prevents the passage of water, so it like seals the cells of the skin and reduces the loss of body fluids, and also it is important from immunological point of view, prevents entry of foreign material. Then the cells die. There are no nuclei, stratum lucidum. Lucidum means clear, and it's only present in thick skin. Most of the skin doesn't have stratum lucidum. It's only in the palm and in the sole of the feet. And then after that, multiple layers of stratum corneum. Cells are dead, and once you scratch your skin, many of them will be lost. But they contain protein, so they are always, usually they are present in our bed sheets and in our blankets. That's why we need to wash them every time, because the presence of this protein there is a good culture media for ticks, mites, and things like that to eat these delicious proteins. So, and the cells here, actually, they are overlapping each other. The cells, they are like, we can say that they are like the scales on the skin of a snake, or maybe they are like the shingles on a roof. This is to show you how keratinization takes place. Stem cells divide, produce more keratinocytes, and as they go up, there's more keratin. Keratin will be bundled, and this journey takes about 4 to 6 weeks. Of course, this journey will become rapid and rapid whenever there is a requirement for more and more keratin, whenever their skin is subjected to friction. So it becomes, or it is removed in abrasion. Whenever there is more and more friction on the skin, like manual workers, for example, they will have very thick stratum corneum, and this is what we call callus formation. So callus is a very thick stratum corneum because of the continuous exposure of the skin to friction, and this will stimulate increased cell production and increased keratin formation, as I mentioned here. The process will be very rapid, and this will be a very thick area of skin, because the reason here is to protect. Now, we are done with the epidermis. Let's move to the dermis. I mentioned that the skin is epidermis and dermis. The dermis is connective tissue, whether it's loose connective tissue or dense connective tissue, but it's connective tissue after all. So it has the cells of connective tissue, fibroblasts, for example, and it has the fibers of connective tissue, the collagen fibers, which make great tensile strength on the skin. It has elastic fibers that can stretch. They are pliable. And the other thing about the epidermis is that it's very important for the survival of the epidermis. Remember here, the epidermis is epithelial tissue, and there are no blood vessels in the epithelium. Look here, there is a plexus of capillaries and small vessels that are just underneath the epidermis, and it is this plexus that is so vital for the epidermis. So it is so vital for the survival of the epidermis, because the epithelial tissue, as we mentioned previously, has nerves, but it doesn't have blood vessels. It is the dried dermis that is used to produce leather from animals. Cellulite is the appearance of like dimples, nodularity, bumps on the surface of the skin of some women, because in women in general, the dermis is thinner than the dermis of the male. And here, the dermis is very thin. In addition to that, there will be herniation of the subcutaneous tissue, which contains fat. So it will herniate into the dermis, and this will be reflected as epidermal dimples called cellulite. The dermis is divided into two regions: a thin superficial region, which is about 1/5 of the thickness of the dermis. It's called the papillary region. And the reason, papilla means it's like nipple, so or finger-like projections, multiple finger-like projections that are present at the junction between the dermis and epidermis. And evidently, this will increase the surface area of contact between dermis and epidermis, prevents separation between them, because you know that there's always, the skin is subjected to pressure. So that's why they are taller, they are more numerous in areas that are subjected to mechanical stress, because this is one of the functions of these ridges. And they just give an appearance of like an egg box. You can see it here. They have, in thick skin, they have a pattern, a certain pattern, and this will be reflected on the surface of the skin as the epidermal ridges that produce the fingerprints. That's only in thick skin. They contain blood vessels, which are important for not only for the dermis, but for the epidermis, and contain a lot of receptors, whether encapsulated or non-encapsulated receptors. One of them, you can see it here, it's called the Meissner corpuscle. Okay, it looks like a skein of wool, the Meissner corpuscle. Now, the reticular region, which is the thicker, deeper region, consists of dense, irregular connective tissue, and it is deeper to the papillary layer. It is thicker than the papillary layer, and these collagen and elastic fibers, although it is dense, irregular connective tissue, but in most places there is a pattern in them. So they have a certain direction. Most of them, not all of them, like in a tendon or a ligament, which constitutes a dense, regular connective tissue, but there is a certain pattern, and this is reflected in the form of what we call Langer's lines on the skin. Of course, we cannot see these lines on the surface of the skin, but we can imagine them, as you can see here, the Langer's lines, which are present. Look at the lines here. These are imaginary lines. They are circumferential, mostly circumferential in the trunk, but they are more longitudinal in the limbs. And also they are circumferential in the neck. So the reason of knowing this is good for the surgeon, because when you are intending to do a surgical incision, it's better to do the surgical incision parallel to these Langer's lines. Because if the surgical incision is done perpendicular to these lines, then these lines are the lines of tension in the skin. They are the lines of where the collagen and elastic fibers are located. So they will tend to pull apart the sides of the incision, and the incision gapes, and when heals, it heals with a lot of fibrous tissue and scar tissue. That's why planned surgical incisions, they should be done parallel to these Langer's lines, in order so that not to subject the skin incision to a lot of pull from the fibers that are present underneath the skin. You can see here, for example, this is a planned a planned incision of a patient with who underwent thyroidectomy, removal of the thyroid gland, and you can see that barely you can see the incision because it is parallel with Langer's lines. So it will heal with minimal amount of scar tissue. Scar is fibrous tissue. This collagen and elastic fibers, of course, we are going to lose them with advancing age, and this will result in wrinkles of the skin. If they are damaged because of overstretching that takes place in obesity or in pregnancy, they will result in the formation of striae on the surface of the skin. And just to remind you that it is the dermis, which is the site where the ink of a tattoo is deposited, because the dermis does not change. It's there. It's not like the epidermis, which is constantly renewing itself. So if you deposit something on the epidermis, then within 4 to 6 weeks, it's going to disappear, because the whole journey from the stratum basale to the stratum corneum until it's shed takes 4 to 6 weeks. But this doesn't happen in the dermis. So that's why the ink of the tattoo is deposited in the dermis. These are the epidermal ridges. I mentioned them probably now twice, just to repeat that they have special pattern, and they are only present in thick skin, and this pattern conforms with these papillary ridges that are present between the dermis and epidermis. They improve the grip, and because they increase the surface area of the epidermis, they counteract mechanical stress, increase the surface area for tactile activity, and definitely because they have a unique pattern in individuals, so that's why they constitute a basis of identification. So dermatoglyphics for the identification, that all of you now are using it every day when you open your phone, your computer. So you are using these epidermal ridges of the thick skin of the tip of your finger. In the skin, there are hairs, and each hair is composed of dead keratinized epidermal cell. It has a shaft. So the shaft of the hair is located above the surface of the skin, and it has a root which is below the surface of the skin. Both of them, they consist of three-part, a medulla, a cortex, and a cuticle. And the cuticle, again, it contains dead cells. It's like the cornified cells that are present in the stratum corneum. They overlap each other. So there's a shaft and a root, just to remind you, shaft and root under the skin. And the root is surrounded by a follicle, a hair follicle. In addition to that, the root is distended here. And so it gives like the appearance of an onion bulb. And that's why it's called the bulb of the, which is located at the base of the follicle. So the base of the follicle is distended, and there are blood vessels, as you can see, multiple blood vessels. And there is another layer here, which is called the hair matrix. And it's like the stratum basale. So it contains stem cells and contains melanocytes. And it is these cells that are going to multiply and die and form the hair itself. So they are always, this hair matrix, this layer of hair matrix here, is always multiplying. And there are melanocytes in between them. And because of the presence of these melanocytes, they will attract the heat of, for example, laser machines. And so this will result in the burning of the hair, and the hair will be lost. And at the same time, because they are multiplying, therefore chemotherapeutic agents which attack cancer cells, one of the features of cancer cells is that they are rapidly dividing cells. So chemotherapeutic agents, usually they attack rapidly dividing cells. One of the rapidly dividing cells that are present in the body are these cells that are present in the bulb of the hair. And so there will be loss of hair when a patient is taking a chemotherapeutic agent. Not only hair, but also like chemotherapeutic agents also attack the rapidly dividing cells, for example, that are present in the bone marrow, which results in reduced immunity because of the reduction in the amount of white blood cells. We will talk about this when we deal with the blood and the cardiovascular system. The color of the hair, like the color of the skin, results from the melanin produced by these melanocytes that we have just mentioned about them. So the dark hair contains true melanin. Blonde hair, as I mentioned. There's another type of melanin which contains like iron and sulfur. So it's like yellow or red hair becomes, and sulfur. And when it's gray, there's less amount of melanin. But in addition to that, the gray hair has air bubbles between its layers, between these layers of the medulla. So there are air bubbles in it. So that's why it looks like a gray. Also in the white hair, there's no melanin at all, and there are air bubbles. There are certain structures related to the hair. One of them is called a smooth muscle fibers. We are going to talk about muscles later on, and we will see that there are three types of muscles. There are skeletal muscles, most of the muscles that are named in the body at least. And then there are cardiac muscles, which are present only in the heart. And there are smooth muscles, which are present everywhere. So they are usually present in tubes. So they control the lumen of the tube, dilate or contract, for example. There are smooth muscles present in the pupil of the eye. We'll talk about it later on. Dilator pupillae and sphincter pupillae. This is another group of smooth muscles, which is called arrector pilorum. So arrector pili or arrector pilorum, it means the muscles that cause erection or straightening of the hair. Of course, these are supplied not from the somatic nervous system, but the autonomic nervous system, the nervous system that is not under our volitional control. So they are supplied, to be specific, from the sympathetic nervous system, which prepares our body for what we call fight or flight. So these are important, for example, in animals when they contract, when the animal wants to fight or flight. This will cause erection of the long hairs of the animal, and the animal becomes more intimidating or scaring for others. But it's also present in human. So that's why, and result in what we call the goosebumps that we have whenever we have like fear or whenever we have cold. The reason is that these muscles contract in cold weather is that straightening the hair will create a very thin layer close to the skin where the air is trapped, and air is an insulator. And as you can see here, it's the same mechanism that is used, for example, by this pigeon when it fluffs the feathers in cold weather to create a thin layer of air close to the skin that acts as an insulator in cold weather. In addition to that, hair is connected to a plexus of nerves, free nerve endings here, and these are for pain and for touch. So it's easy to feel if when the hair is moved, you can easily feel that. And when you pluck your hair, especially in certain places like here, it will be very painful, okay? But when you cut the hair, it's not painful, because plucking the hair means that you are removing it from the roots, and the plexus is related to the roots, but there is no nerve related to the shaft. When you cut your hair, you cut the shaft has no nerve supply. So that's why cutting the hair is painless, while plucking the hair is painful. Functions: it prevents heat loss, as I mentioned here, forms a very thin layer of air, decreases sunburn, protects against sunburn. You don't expect that this guy with a lot of hair on his chest and his shoulder will be exposed to a sunburn if you compare it with this poor girl who got sunburned because of these windows in her jeans. And the eyelashes, they help protect the eyes, and we have also, as I said before, that it is for touch receptors. There is hair root plexus that senses the touch. Sebaceous glands, we mentioned about sebaceous glands before. I just want to remind you that they are present in the dermis, and their ducts, they open, as you can see here, their ducts open into the hair. So that's why they are important for keeping the hair and skin soft and pliable. The way that they secrete is an holocrine secretion. They produce the sebum, which consists of like cholesterol, protein, some fat as well, fat and protein, and then they will explode. The whole cell ruptures and releases the product. what happens in acne, that there is the openings of these glands will be blocked, and so the sebum will be accumulated here, and certain types of bacteria will infect it. So that's why it's always advised to clean the skin in order to open the pores for these sebaceous glands. The sweaty glands, in general, all the sweaty glands in the body, they are eccrine merocrine glands. The secretory portion is present here in the dermis, and they have their ducts that open on the surface of the skin. But some of the sweaty glands, of course, these are important for perspiration, controlling body temperature and in perspiration. But then we have another type of sweaty glands. They also secrete by merocrine secretion, but originally, I mean, when they discovered them to start with, they didn't think so. So they called them apocrine sweaty glands. An apocrine gland, just remember, an apocrine gland is a gland that secretes when the apical portion of the cell is pinched off, like in the breast. So the only example we have in the breast. But they thought that those glands, they secrete by apocrine secretion, because these glands are not involved in perspiration and control of body temperature. They open into the hair follicle, they open into the hair like sebaceous gland, unlike the most common type of sweaty glands, and they are present in certain regions in the body, especially in the armpit, in the axilla, and in the pubic region, around external genitalia and the anus. And so their secretion is more viscous, and it causes body odor. And usually they don't secrete in response to heat, but they secrete in response to emotional stress and sexual excitement. So they have almost the same structure. The only difference is that their ducts open into the hair, not directly onto the surface of the skin. And the second thing is that they are located in certain locations in the body. The nails, also here we have, they are tightly packed keratinized cells. We have a nail body, which is usually pinkish in color. They are dead cells, dead packed keratinized cells. It's usually pink because we can see the underlying capillaries, which contain blood. It has a free edge, which is whitish in color because there are no underlying capillaries, obviously. And then there is a small lunula. A lune, la lune, like in French, means moon. So it's a small moon here, a lunula, whitish. And here, this area has a very thick stratum basale. It's the place where nail is being formed. So it has very thick stratum basale. That's why the underlying capillaries are not shown. We cannot see them. It's not transparent. So it looks whitish in color. Then we have a very thin rim here of skin, which is called the eponychium or the cuticle, and then the root. From proximal to distal, there is the root, there is the eponychium, there is the lunula, the body, and the free edge. And obviously, the nails, they enhance grasping, manipulation, and protect against trauma at the ends of the digits. And don't forget, you use them for scratching. Best thing to scratch is to use your nails. Functions of the integumentary system. It regulates the temperature of the body by several mechanisms. Sweating is a perspiration through the sweaty glands. They control the blood flow through the skin. I'm sure that you have noticed, if you are practicing in the gym and you notice that your superficial veins will become distended. Unlike in cold weather, you cannot see your superficial veins under the skin. The reason for that is that these superficial veins, the circulation, the superficial circulation, what we call peripheral circulation, increases when there is increased temperature of the body in order to dissipate the heat out of the body. So this is done through the skin. So controlling the blood flow of the skin, and also by controlling the erector pylorum, which causes the goosebumps, and a layer of insulating hair. So all these are methods or structures that do that. Sweating, like you know that in dogs, for example, they don't have sweat glands, and that's why in order to control their temperature, they pant, so that to use the mucus glands that are present in the mouth and in the tongue, and also to exchange the air, the hot air in the lung. The reason is that they don't have sweat glands like humans. So one of the functions is to regulate body temperature, store blood, protect body from external environment and microorganism, radiation, melanocytes, chemicals, and detect sensation. We have a lot of sensory receptors in the skin, as I mentioned. We're going to talk about them: pain, touch, and temperature sensations. Excrete and absorb substances. Some drugs and medications are given through the skin, like, for example, the nicotine patch, which is attached to the skin to be absorbed through the skin. And last but not least is that it synthesizes vitamin D. If you watch the video at the beginning for Gunther von Hagens, come back here to the last slide and read about this painting of Michelangelo. Okay, thank you.